Today's topic is construction of power triangle. This topic is really very important. The reason is it is an application oriented topic. Whatever concepts we discussed earlier, all of them used in this topic. It's a concept oriented, application oriented. That's why it is important. And it is also difficult to understand correctly. A lot of thought process is involved to understand it properly. So there are many hidden concepts involved in this. So please listen carefully. This topic contain following topics: current through pure capacitor, current through pure inductor, current through resistor, then current through inductive load, impedance triangle, voltage triangle, current triangle, power triangle, then various powers, importance of each, significance of each, then conventional problems, objective type problems, and so on. So like that we discuss. So let us start with current through pure capacitor. Pure capacitor means capacitor without any resistor. So AC voltage is applied to pure capacitor. So how this current behavior we have to find. AC voltage source. That is V equal to Vm sin omega t. What is the phasor form? V of angle 0. And I am taking capital V. This is RMS value. So V is equal to Vm by root 2. Vm by root 2. So how this current behavior? Let us find. So I is equal to I of t is equal to C dV by dt. Is C d by dt of this V equal to Vm sin omega t. So differentiation of this is Vm C then omega cos omega t. We can also write it as Vm by omega c is 1 by omega c, and cos omega t I can write it as sin omega t plus 90 degrees. Sin 90 plus theta equal to cos theta. Voltage by 1 by omega c. 1 by omega c is the capacitor reactance. The voltage by reactance is current. This is nothing but Im sin omega t plus 90 degrees. So again, if I change into phasor form, it is I of angle plus 9. So therefore, current leads, plus 90 means leading. Therefore, in pure capacitor, current I leads V voltage by 90 degrees. So this is one important point. So we can also show in a phasor form. This is the applied voltage V of angle 0. So current is leading by 90 degrees. So this angle is plus 90. This is plus 90. This is current I. So phasor form representation. This is mathematically proved it. Then how the power waveform, power will be. Power is P of T. P of T is nothing but V of T into I of T. So what is the voltage applied? Vm sin omega T. Current is Im cos omega T. This is equal to Vm Im sin omega T cos omega T. We can write it as sin 2 omega T by 2. By 2 is nothing but root 2 into root. So which is equal to Vi sin 2 omega T. This is instantaneous power. But what is the average of this? P of T average. This average value is indicated with the capital, which is equal to 0. Why this average is 0? It's a sine wave, na? Sin 2 omega T. Any sine wave, positive half cycle area, negative half cycle area equal. So compulsorily this average value is 0. So that means what? Instantaneous, second point, instantaneous power frequency is double the input signal frequency. Instantaneous power frequency is double the input signal frequency. Then pure capacitor average power dissipation is 0. In pure capacitor, average power dissipated is equal to 0. Okay. So first statement is current leads voltage by 90 degrees. Second statement is instantaneous power frequency is double the input signal. Then average power is 0. And let me draw these graphs. How graphs looks like. This is the applied voltage waveform. What we are applying. this is V, and current is leading. Current is leading. Leading by 90 degrees. Leading by 90 degrees. This is the current wave. Now the power waveform. Power waveform is product of voltage and current. So this is power waveform P of T. So here positive product is positive, and positive negative product is negative. So power waveform looks like positive, negative, positive, negative. Why this is positive is product, positive product is positive. Here positive but negative product is negative. Negative product again positive, and positive negative product is again negative. So in one cycle of duration, this power waveform is completing two cycles. So that's why it is at 2 omega. If voltage frequency is omega, what is power waveform frequency is 2 omega. So frequency is becoming double. Not only that, what is the average of this? What is the average of this? This average is 0. Why this average is 0? Positive area, negative area equal. So average of this is 0. Next, when we see energy behavior, energy E of T or EC of T. What is the formula of CV square? The voltage positive square is positive anyway. Negative square is also positive. If you see this voltage waveform, so integration of the power, it is increasing. So here energy increase like a reverse umbrella shape. Then V square So it will vary like a sinusoidal. You see V maximum here, square is maximum. Then V0 square is 0. Then negative maximum square is positive. So like that it will go. So energy variation is like a sinusoidal. It will go to positive peak, again come to 0. That means what? Capacitor is having highest energy when V is maximum. So voltage is 0 means again energy is becoming 0. Or even if you think like integration of power, this positive area is integrating in, so it is increasing like a reverse umbrella shape. Then this negative area is added to positive, again decreasing like a umbrella shape. So like that it will go sinusoidally. So these are the 4 observations mathematically. Current is leading voltage by 90 degrees. Instantaneous power frequency is double the input signal frequency. Average power dissipation is 0. Energy vary sinusoidally. These are the 4 important conclusions. So we are analyzing this in 4 different ways. One is mathematically, second is phasor representation, and third one is mathematically, graphically, how we can show graphically. And fourth one is this is actual symbolic representation. AC source symbol, capacitor symbol, current is a symbol. This is what a symbolic representation. But in the actually source is different. Capacitor physically how it is appearing is different. So, but this is a symbolic representation of the topic. And we are analyzing mathematically, analyzing phasor form, analyzing graphically. And the conclusions remain same, but you have to think these different way. Graphically, if you plot, you'll understand better way. Phasor form, sometimes that will help to understand correct way and so on. Okay, so these are the 4 important conclusions for pure capacitor. A frequently asked doubt in this topic is when voltage is 0, current is maximum. When voltage is maximum, current is 0. General concept is what? Current depends on voltage. When voltage is 0, how come current is maximum? That concept is applicable to resistor, but in the capacitor functionality is different. As per Ohm's law, I is proportional to V. When V is 0, I is also 0, no doubt. That is for resistor. But capacitor concept is different. If you look at or if you imagine capacitor is having some resistor, if it is having some resistor R, then this applied voltage V will not drop totally across capacitor. But what we are plotting is this V, voltage developed across capacitor. This V, this voltage versus resistor. So there is always some drop across resistor. So when we plot voltage and current, when voltage drop in the capacitor 0 means capacitor short circuit. When capacitor is short circuit, maximum current will flow in the circuit. When capacitor is fully charged to applied voltage Vm, then potential difference across resistor is 0, then current is equal to 0. Voltage maximum means current 0. Voltage 0 means current is maximum. So this clarity, better way you can understand with the resistor. But what we are plotting without resistor, applied voltage drop in the capacitor both remain same. So better clarity will come if there is a resistor. Remember, we are plotting for our voltage across capacitor versus current flowing through capacitor. So when there is no voltage at all, it is like a short circuit, it demand high current to flow. If it is already charged to maximum voltage, current will be minimum. So understand in that sense. So therefore, when voltage is 0, current is maximum. And graphically, graphically, we are showing like current is leading. Leading means it should touch the time axis before the voltage. So that's why it is a leading waveform. So these are the important conclusions. Same way, current through pure inductor. Current through pure inductor. Current means current, voltage, power, energy, everything we are analyzing. So V equal to Vm sin omega t as usual. V of angle 0. Pure inductor is L. We want to understand behavior of I of t. So what is I of t equation? 1 by L integral Vm sin omega t dt. So this is like Vm by omega L integration of sin minus cos omega t, which is equal to voltage by inductive reactance is current. So Im minus cos omega t, we can write it as sin omega t minus 9. So because of this minus 90, current is lagging. So what is the phasor form equivalent? I of angle minus 90 degrees. So therefore, in pure inductor, current I lags voltage by how many degrees? 90 degrees. This is the first conclusion. Then we can also show phasor representation. This is V of angle 0. This phasor form is looking like a vector. So vectorially I am showing, but always use word phasor because behind phasor form back end is a trigonometric function. Use always a word phasor form only. Don't use we are showing like a vector, but don't use vector form. Better use right word phasor form, and so on. Then current is lagging. So lagging is negative minus 90 degree. These are all intermediate applications. Whatever you study, intermediate trigonometry. So trigonometry, if you are really good, confident, this topic you can easily understand. Clockwise is angles. Angles clockwise is always negative. Counterclockwise is positive. So current is lagging voltage by 90 degrees. It's a phasor form representation. Then coming to power, P of t is V of t into I of is Vm sin omega t. Current is Im sin, or I can write minus Im cos omega t. This is minus Vm Im sin omega t cos omega t is nothing but sin 2 omega t by 2. By 2 is root 2 into root. So which is minus Vi sin 2 omega t. So what is average of this? Average is always indicated with a capital. Capital P. Capital P is nothing but small p of t average is equal to 0 because it is also symmetrical sine wave. So if you integrate, you will get compulsory 0. So in pure inductor, average power dissipation is also 0. In pure inductor, average power dissipation is 0. Pure inductor average power dissipation is 0. Now again, let us draw the graphs mathematically. This is the applied voltage waveform, what we are applying. This is the current waveform. Current is lagging. So we can extend back further. This is voltage V, current I. So positive negative product is negative. Start with negative. Then positive positive product is positive. Again positive negative product is negative. Negative negative product is again positive. So negative, positive, negative, positive. Draw like a sine wave. See all graphs I am drawing on pen tab. So it is a blackboard waveform looks decently. So it is difficult to draw perfectly on the pen tab. That's why shapes looks like little bit odd, but understand. You can draw on the paper correctly, better. They're all sine waves. So what is the average of this again is 0. Then energy EL of T is of L I of T square. So first current started with negative maximum. So square is positive maximum. It will start here. Again it will come to 0. Then go to positive maximum. Again come to 0. Again go to like this. It will go. Again it's like a sine wave. So energy in inductor vary sinusoidally. Power also varies sinusoidally. But this frequency is 2 omega. Double the input signal frequency. So what is the first point to be noted? current to lagging voltage by 90 degrees. Second point, instantaneous power frequencies double the input signal frequency. Then average power dissipated is 0. Fourth one, energy in inductor vary sinusoidally. These are the 4 points you should remember. What are the changes comparing with capacitor? Capacitor leading, here lagging. Their frequency double, here also frequency double. Their average value 0, here also average value 0. Their instantaneous, there also energy varies sinusoidally. Here also energy vary sinusoidally. The basic difference is there power first positive, negative, positive, negative. Here negative, positive, negative, positive. That is only the difference. And conceptually, if I go back again, same current through capacitor, what is the meaning of power positive? Power positive meaning, power negative meaning is what? Power positive means the source is giving power to capacitor. Power is transferred to capacitor. Power negative means power is coming back to source. Power negative means it is coming back to source. Power positive means power is going to capacitor. But is it really power going? Power going means source giving, capacitor taking, or on its own going. Then power coming back. Power coming back means capacitor giving, power on its own coming back, or source is taking, which is correct. Many students will give wrong answer. The actual answer is source only giving, source only taking. Capacitor best example is bucket. Na? We take water from bucket, or water bucket will give the water. We take water from the bucket or bucket will give the water. Bucket cannot give the water. Na? We only take the water from the bucket. You ask bucket, give me water. Bucket will not give. You have to go there and take the water from the bucket. So finally, who is taking water? We are only taking. To fill the bucket with water, you have to send water. Na? That means what? Source only giving power to capacitor. Source only taking power from the capacitor. Capacitor cannot take, cannot give. If you want to use it, use it. So capacity is like a storing element. Bucket will store water, and bucket will not tell any objections. So why are you taking water, or why are you filling me with water like that? If you want to fill the bucket with water, you can fill. If you want to take water from the bucket, you can take it. So ultimately, power is going to the capacitor means source is sending, source is giving. Power negative means power coming back from capacitor to source. Coming back means on its own it will not come back. Capacitor will not give. Source only will take. Then why source is taking? Why source is taking? Whatever power is going into the capacitor, total power source is taking back. In this process, what is the loss of power in the capacitor is 0. When you transfer 5 liters of water into bucket, you can take 5 liters of water as it is. Na? Bucket is not consuming any water. Bucket is not eating the water. So bucket is just a storing element. Therefore, the average power dissipated in the capacitor is 0. Whatever quantity of power is going into capacitor, in totally coming back. So therefore, the average power dissipated 0 means in the process of sending and taking, net power loss is 0. That is the meaning. And also don't think that source is not working. Work done by source is not 0. Average power dissipation only 0, but energy I mean, work done by the source is not zero. Source is continuously doing working. Why it is working? To send power, it has to work. To take water from the bucket, you have to work. To send water into bucket, we have to work. So work done by source is not zero. Don't get confusion between power and energy. So energy is based on work done. Source is continuously doing work. What kind of work it is doing? Sending power to capacitor, taking power from the capacitor. Sending energy to capacitor, take the energy back to source. So it is like a oscillation continuously. This work is keep on going on, and therefore useless work is going on. Useless work. I can give many examples. You throw a ball to wall, then ball is reflected back. Again you are catching. Again throw. Again take it. Again throw. If you throw a ball from the window, it will go out. Ball will not come back. I can give another example. You eat 100 grams of food, vomit 100 grams of food. What is the food utilized to your body? Zero. But for eating, you have done some work. For vomiting also, you have done work. Work done by you become waste. Or you go to bank, deposit 100 rupees. Again come to home. Again go to bank, withdraw 100 rupees. Again come to home. You do this job whole day. But 100 rupees remain same only, na? And if you go by auto, come by auto, that 100 rupees become zero. Imagine you are going by walk and coming by walk, but you are taking breakfast, lunch, dinner, work done by you becoming waste. So in this example, waste work is going on. Source is doing a waste work. It is doing work, but work is waste. Waste means no utilization. No utilization means whatever power going, total power coming back. So waste work is going on. That is the concept of this. The same way, even in inductor, reverse process. Earlier I said the example, eat 100 grams of food, vomit 100 grams of food. Here vomit 100 grams of food, again eat 100 grams of food. It's just reverse process. Negative, positive, negative, positive. Here also average value 0. So exactly same concept, just reverse. Okay. So here voltage and current are orthogonal. Orthogonality means 90 degrees. Best enemies. Best enemies. So best, for example, two roommates are enemies. One want to go to movie, one wants to go to hotel. So they are differ in their opinion. Finally, they cannot go to hotel, they cannot go to movie. So work done by them become zero. That's the concept. And if it is a resistor, how it will be? Current through resistor only. We cannot tell pure resistor. Resistor is like a impurity. So resistor only. Current through resistor only. V equal to Vm sin omega t, V of angle 0, resistor R, current I. So I of t is equal to V by R. Is nothing but Vm by R sin omega t. So this is Im sin omega t. And phasor form is I of angle 0. So current is in phase with the voltage. Therefore, in resistor, current is in phase. in phase with the voltage. So they are like best friends. Whereas pure capacitor and inductor, they are like best enemies. Phasor form, if this is V of angle 0, this is I of angle 0. So both are in phase. Then mathematically, V of t equal to V of t into I of. Vm sin omega t, Im sin omega t. This is equal to Vm Im sin omega t, sin square. Sin square omega t is 1 minus cos 2 omega t by 2. By 2 is root 2 into root. So it is equal to Vi minus Vi cos 2 omega t. So what is average of this is capital P is equal to Vi only, Vi watts. Because Vi minus Vi cos 2 omega t, when you integrate, what is average of cos function is 0. Average of Vi equal to Vi only. So Vi watts. So in resistor, average power dissipation is always given by Vi watts. This V is not DC voltage. What is this capital V? Vrms. I is Irms. So Vi watts. You can also draw the graphs, graphical representation. So this is voltage waveform. And current is in phase. Both will start at the same time. This is V. This is I. So positive is positive. Negative product is positive. So this is positive. This is also positive. This is P of T. What is average of this? Average of always positive average is not 0. Na? So therefore, this is Vi. That's a meaning. But what about energy integration of positive increasing? Again, always positive. Na? So it will go like this. It will increase like umbrella shape, reverse umbrella shape, again umbrella shape, So like that, it will go. So this energy, integration of P of Reddy or I square or V square by R. So why it is increasing continuously? Because power is always positive. Always positive means cumulatively energy increases. So resistor is always dissipating a positive power. Power into time is energy. Energy also increases. That is the meaning. So first one is current in phase. This is the phasor form. Instantaneous power frequency here also double the input signal frequency. Here also frequency is double and energy increasing like a snake pattern. But here continuously increasing, never come back to zero. So that is the meaning of energy. So capacitor alone we have done, inductor alone we have done, resistor alone we have done. Next class we'll discuss how it will be for inductive load. So I am stopping now.